Hello, I'm Patrick Hogan, NASA Earth Scientist Emeritus and advisor to Facing Future. I am delighted to welcome Dr. Peter Wadhams, one of the world's foremost experts on polar science, who has been on over 40 research expeditions to the Arctic. Dr. Wadhams is also the author of the widely read book and TED Talk, A Farewell to Ice. Also with us is Mark Anderson, a visionary in the field of technology and CEO of Strategic News Service. Peter, you're about to once again embark on a voyage to examine conditions of the Arctic, where recent developments are providing high drama: the shrinking Arctic ice sheet, the methane releases in Siberia, and the rapidly shrinking Greenland ice sheet. Climate scientists have stated that we are beyond several tipping points, given the Arctic is now experiencing some never before events. What do you consider to be the top tipping points for a warming Arctic? And what might each portend for weather patterns across our planet?
Well, one of the tipping points is definitely the really accelerating loss of ice from the Greenland ice sheet. And this is something that I came upon. I didn't come upon it suddenly, but I spent most of my time working on sea ice. But once I started to look at the ice sheet, the problem there is that it's not going to get any better. With sea ice, we have the problem of can we try to bring it back? And I don't believe we can, but we can try. But it's going, and that's having a knock-on effect on so many things on the planet. But the trouble with the land ice, the ice on the Greenland ice sheet, is that its decay is steadily increasing. This last week, for instance, it was about 9 billion cubic meters, and the biggest single day's loss ever happened to be on a day I was standing on it in 2019, which was 12.5 billion. So there's not that much difference. We're getting 8, 9, 10, 12 billion tons of ice disappearing from the Greenland ice sheet every day in the summer. It melts away, goes out to sea. So we're contributing to global sea level rise. Greenland has become the largest single contributor to global sea level rise, and it seems to be something that's steadily increasing. It's not something where we're going to be able to fix it, unlike some other phenomena concerned with the Arctic and the polar regions, like can we stop methane emissions or something like that. But stopping sea level rise due to melt of the ice sheet is just something, it's something inexorable, and is getting more and more rapid all the time. So it's going to be the source of a great deal of discomfort for human beings in the years to come, as the coastal cities and coastal regions experience an acceleration in the rate of rise of sea level. So that's certainly one thing, is a tipping point that's already happened, which is acceleration of the loss of ice from Greenland. Then another one that's already happened, of course, is the loss of sea ice, and that's something that, well, I first spotted it about 30 years ago, when I was measuring sea ice thickness every year from submarines, and it turned out suddenly the thickness was started to go down, and it was going down significantly fast. And as it went down, the sea ice limit started to come in, leaving lots of open water around in the summer. And that's something which has continued and is again an accelerating effect which won't go backwards. It's going to continue until we have completely open water in summer, and then who knows what's going to happen after that. So, and I guess the third one, if we need to name three, is associated with that, and that's the fact that with so much open water in the Arctic in summer, the water is warming up, because the area of open water in summer is the shallow part of the Arctic, the shelf areas. They're only about 100 meters of water. So when the ice goes, the water warms up, and when the water warms up, it releases a lot of things that are sitting at the bottom, which is mainly methane, the sort of methane in sediments in the shallow water, held down at the moment by a permafrost layer, but that permafrost layer will soon melt, and then we're going to get large amounts of methane coming out into the atmosphere. We'll have a kind of methane outbreak, and that is something that we don't know how to deal with. I know various groups are working on getting rid of methane, but it gets rid of itself after about 10 years. It oxidizes, but during the time when it's releasing material, it really is a very, very powerful greenhouse gas, and we don't really know how to get rid of it. So that's another huge problem that we've got, which is more immediate, because the methane outbreak is going to be something that probably happens within a very few years.
When will the melting of the ice come to a point that you can measure it in meters? I mean, how many years will it take to do that? But even if that's true, my sense of it is that the heating that's causing that melting will actually affect climate far sooner and more dramatically in terms of weather conditions than the rising sea level, which is going to take much longer to have a significant effect on the shorelines. So it's like talking about sea level rise. It's almost like, duh, okay, yeah, but that's nothing compared to the degree of effect to us via weather patterns.
Yes, you're right. I mean, there is a whole new, the three trends I talked about are continuing trends, but the weather events are quite new. I mean, I can remember when such things had never been dreamed of, which is only about 10 years ago. And then when you started to get these events, which really are climate events, it's just when you have enough weather events happening all together and not stopping, it really becomes a climate event. And the climate events are really unexpected. They can be extremely dangerous and destructive, as we know. And it again, the trail of criminality leads back to the Arctic again, as nearly everything seems to do. And the most likely explanation for the weather events is of course that the warm air mass over the Arctic is catching up on the temperature of the cold air mass over the Arctic is catching up on the temperature of the warm air mass lower latitudes. The temperature difference is going down, and that's reducing the strength of the jet stream, and that's breaking up into fragments which cause extreme hot and extreme cold events in places where people live and where people are trying to grow crops. It's all the places where we are. So again, the Arctic is the cause, the Arctic warming up faster than the tropics, but the effects are worldwide and unpredictable as well. So it's doubly bad and triply bad as well, because the places where it happens are the places where we grow most of our crops. So you're right in saying these weather events, which only seem to have been getting more and more frequent over the last decade or so, are a really severe threat.
Well, whether it's droughts wiping out crops or enormous storms that actually don't move, they just grow, those effects in terms of shredding the infrastructure for life on this planet, I think, in my sense, is going to come far ahead of anything in terms of impact due to sea level rise. And that's my last question or comment.
Well, again, I think you may be right, because something is going to cause everything to fall apart. Sadly, the changes that are incremental are not necessarily ones we can deal with or get rid of. And we can't get rid of sea level rise, and we can't get rid of we can't bring back sea ice, although some people think we can. But
Well, you can geoengineer anything, but that's not true.
Yeah, well, that's the other problem, that if we're depending on engineering to solve all the problems which we've created, then it's going to make things probably worse. But yeah, the extra effects of extreme weather impacts on incremental changes is likely to bring about some sort of collapse. I mean, because you get more than one thing going on at the same time. Just here in Italy, 2 days ago, there's been a gigantic fire in Sardinia, and in fact that's the place I'm going next after Greenland. And this is a part of Sardinia that I know pretty well because my wife's family comes from there. So it was a massive fire, which hasn't happened before. You haven't had brush fires in Sardinia, although there's a lot of brush. But right in the middle of that, some friends were flying from Cambridge to Sardinia, and there was a most gigantic hailstorm, and resulting in the plane crashing and the cabin windows being knocked out, and it made an emergency landing. Now, hailstones that big have never been seen before here, but it happens at the same time as half the island is on fire. So with extreme events, you can get extreme events of different kinds, seemingly completely different, in fact, happening at the same time. Floods and floods going on at the same time as drought going on somewhere else. So that's because that's so difficult to predict. The effects are likely to be more dramatic and more destructive of day-to-day life on the planet.
So with that, I'm going to pass control of this to our friend Mark Anderson, CEO of Strategic News Service. And Mark, you are now the host.
Hi, Patrick. And hi, Peter.
Hi.
To be joined to talk with you. So Peter, you anticipated my first question, so that's out the window already. But maybe just a brief reprise here. I'm going to really go to the dark. I think you probably thought you already went to the dark side, but I'm going to go a little darker. Instead of saying tipping points or trigger points, do you feel like there's a point of no return? And have we crossed that? And by return, I mean any chance, and I think you partly answered this already, any chance to get back to what we would call normal?
Well, it's in fact the proper definition of a tipping point is that you can't go back. It's because it came from the experiments on Hooke's law, which you do at school, where you stretch a wire and it keeps stretching and it goes back to its original length. And unless you really hung too big a weight on it, then it doesn't. So tipping points are where you've hung too big a weight on the planet somewhere. And I think we're not going to, I think we're not going to be able to get back to certain things, like sea level rise. A tipping point has happened here because with the climate warming, ice sheets melting, flooding, there's no way to reverse that really. Whereas sea ice loss, I think that's also a tipping point, but the very hopeful people think that we can bring back the sea ice.
Yeah.
In fact, just yesterday, David King produced a very nice program about let's refreeze the Arctic. But in the end, the program didn't tell you how they intend to refreeze the Arctic. And that's always what happens.
Do you anticipate, and this is not just about the sea, but do you anticipate, or just, not just about ice, is there going to be another level of disaster near term? As we see these events you're describing, where multiple storms begin to become one storm, or multiple fires become one fire, when these fires create their own weather, and when that weather becomes what we would then call climate, is there a point where all these things build together, even though they're separate to begin with, and create some kind of cataclysmic event, that catastrophic event that and to finish this question, I see people saying, well, 2030 I'll be dead by then, or 2050 I'll be dead by then, or 20, who cares, I'll be gone. And I'm worried for them, even those short-term thinkers, that we may be facing a near-term cataclysmic event of gigantic proportion, which has been not foretold yet, really, except in movies.
Yes, I think that could well happen. And you're right, people think, especially people my age, think, oh, well, you know, if disaster is coming in 2050, you know, I'll be in my 90s, so I won't care. But it's going to happen before that, and it could easily happen in a very short time. And you can conceive of the kind of scenarios, like, for instance, just in California, you didn't used to get brush fires, or not very many brush fires, and now every year there's more and more brush fires which amalgamate to produce a kind of a burning out of the whole state, and that could catch fire, so to speak. It could become something where the whole state becomes uninhabitable because of the destruction of towns, the destruction of crops, the destruction of farmland. You end up, you can have a place where you can't live, and that could happen. We could have in the Antarctic, for instance. Again, people are very calm about the Antarctic. Oh, that's something there. It's down there a long way away and nothing will happen for hundreds of years. But already ice shelves are breaking up, and there could be the same kind of rapid transition as we're already getting in Greenland. And then that would accelerate sea level rise even more, but also could cause other impacts on habitable parts of the world, because the sea is everywhere. So
Peter,
sea level
look at the soot being generated from those fires. It's going to be laying on top of whether the snow cover or the ice sheets, which then changes that dynamic.
So,
well, yeah, that's what I'm going to look at in a couple of weeks, is the dirt, the black ice on Greenland, which is worse than it's ever been before. That as the ice melts in the summer, the dirt on the ice stays behind. So the surface gets dirtier and dirtier. That means it gets darker and darker. So it warms up even more rapidly because it absorbs more radiation. So we're getting an accelerated loss of ice because the ice is getting dirtier.
I'd like to make a statement and then follow with a question. I believe that humans are essentially incapable of nonlinear appreciation of nonlinear problems. We're pretty good at straight line. We're pretty bad at nonlinear. And beyond nonlinear, there's another layer of events, which is I would call cataclysmic. So I think we're now looking at that right here together in this meeting and in the world. So every IPCC report that has come out, they begin by saying we have failed to be fully appreciative of the nonlinear characteristics of this collapse. So what I'm going to try to ask you about is I'm returning to what you just said. And I think maybe we're plowing some new ground here in a way, at least for the public. So instead of worrying about something in 2060 or 2030, watching China build a new coal plant a week, and then maybe someday in the 2030s they'll promise something else. I think we're in a more near-term problem here. And so I want to come back to what you were just saying about if there could be a catastrophic, unforeseen event, call it unforeseen, you've probably foreseen it. Give me some time frame. What is the nearest term? Could it be next year? Could it be in 5 years? What's the nearest possible time when a cataclysmic, unforeseen, nonlinear event of mammoth proportions could happen from climate change?
Well, a good question. It can be a very small number of years. In fact, when you mentioned this nonlinear effects, in fact, there was this very famous American scientist, now dead, who said that all of the problems of the world stem from mankind's failure to understand the exponential law. And to assume that everything is going to carry on in a nice steady way. The way that Intergovernmental Panel on Climate Change always showed a steadily increasing sea level, which was completely wrong. But the exponential is something we don't appreciate. We're adding CO2 to the atmosphere in an exponential way, but we don't seem to bother with that. And and yet that goes on getting worse rapidly. So the trouble with an exponential is you're climbing a hill, and behind you everything's flat, and you think, oh, that's nice, and then in front of you everything's getting vertical, and that's what's happening in the world in so many different aspects of the climate. So it's in a way it's any of these exponential changes could be the source of a major catastrophe. But I think you're talking about something that lies outside an exponential. At least you can predict how an exponential will go. You can predict
that's right.
Sea level. You can predict carbon dioxide in the atmosphere.
Peter, let me reframe this, because you and we are talking about, water, and then wildfire, and then weather and climate, and all the various siloed effects. But the way this goes nonlinear is when the siloed effects are cooperative. And
that could be connected with things that we don't even think about, like animals. I mean, the biosphere is incredibly fragile and very, very dangerous. Just if bees disappeared or something, we couldn't grow any crops, and yet we ignore it. We're destroying it, but we ignore what we have to do, how much further we can go and not cause a catastrophe. So there's catastrophes we're not even thinking about, which are there and can happen quite quickly. And
exactly. And so I'm going to pressure you here, Peter. What would be the nearest time in your own? I know it's impossible. I'm giving you an impossible question. I want you to try anyway. You're smart enough to do the impossible. So in your mind, what's the nearest possible time, whether it's minutes, weeks, years, how many years, when these things that seem to have been independent and bad may all kind of begin to become cooperative in some way and create a cataclysmic event?
Well, I'd say it could be as little as 5 years.
Okay.
Because so much has happened just in the last year or two. If we go back 2 years, or 3 years, 2 years perhaps, we see nasty things happening, but they didn't all happen at the same time. And now we're seeing nasty things all happening at the same time and getting worse.
Mhm.
So the acceleration of catastrophes that have happened in the last couple of years, which we haven't noticed so much because of COVID, has been uppermost in people's minds, but the natural catastrophes have been accelerating, and add another 5 years to that, and we could have something truly, truly terrible going on.
Thank you. And I have one more question, and I think I'm done unless Patrick wants to jump back in. Just days ago, I was sitting with a couple of my colleagues talking about this problem. And we came up with a crazy idea, and I want to run this idea past you. I always like to end these things on a positive note, even when it's difficult. So I have an idea that I'd like to share with you and get your reaction to it. And for lack of a better name, we decided to call it Go Light. And what the idea is if all of the if all the leaders in the world became informed with what you just said, we just took this recording and they all got a chance to see it and actually understood what we're talking about here, what you just said, then let's just pretend for a moment, a crazy moment, that they actually responded to the crisis and decided to do something. And that decision, as a group of nations, maybe just beginning with 5 large nations, was to drop all the other financial agendas that everybody's got a sweet spot for. I like apple trees. Well, forget it for a while, you know, and instead spend money on solar energy. And for 5 years starting tomorrow, they did nothing but spend money on solar farms. And 5 years later, and I don't know this, I'm just estimating this, they were able to take a pretty big chunk out of the apple. You know, maybe they got it all done, maybe they got 2/3 of it done, but things that would have taken 100 years or would have taken 50 years, the world got done in 5 years. And you know, in a sense, we went neutral and carbon neutral. So every country did its part. Everybody built solar farms. Countries that couldn't do it, we paid for it. We went to Africa and did it there. So whatever the answer was, the whole world got together, went Go Light, spent the money, whatever the money, doesn't matter what the money is, go into debt. We recognize the difficulty of the situation. This is the worst crisis we've ever faced. We're going to get through it, and here's how. If we did that, what would the result be?
Well, I think it would certainly help to save the planet, but we need to do more besides, because we've got to take carbon dioxide out of the atmosphere, and that's the terrible problem that we've got, because it's unacknowledged that we can reduce our emissions as much as we like, or it would be great to reduce them down to 0 or to a low value, but the carbon dioxide that we put into the atmosphere stays in the atmosphere. So we've got to do more than just reduce emissions of carbon dioxide. We've got to make a gigantic kind of Marshall Plan to remove carbon dioxide from the atmosphere, which means at the moment building all these air capture devices, unless we can think of something better and cheaper and less energy expensive. But if not, we've got to build a whole load of these things and start taking CO2 out of the atmosphere. Otherwise, then we really have had it. So just in inverted commas, going to spend all of our time and money on solar, that will be very, very valuable. But there's still more beyond that, which is get rid of the CO2 somehow, or get rid of some of it.
We've got 10 years ago, we hatched a plan called Carbon Trifecta. And the basic idea was to take the CO2 out of the atmosphere. And instead of saying you have to pay for that process, use the CO2 to make something extremely commercially valuable. And you have to do gigatons a year to make any sense of it. And our thought was to make a graphene related building material that you could 3D print into buildings, so that if you accelerated that whole technology, there's still pieces that are missing, but most of it's there. You could be making cities out of carbon strengthened cement, which cured better, didn't give off as much CO2, and was maybe 10 or 100 times stronger or more. Cities would last longer. It would be commercially valuable. That's the only thing I've been able to think of.
Well, that's great. I mean, because I mean, something like that is being just started on a small scale by a company called Blue Planet in California that turns CO2 into limestone rock, and then you grind up the limestone and you've got sand.
Yeah.
But it has to be, as you're quite right. If you're going to really successfully deal with getting rid of CO2, we need to convert it into something that people need and want and are willing to pay for,
Yes.
and is needed in 40 gigaton per year quantities.
There you go.
So pretty much building materials is about it. Yeah.
Yeah. Okay. Well, I really appreciate having been able to talk with you this morning. And as tough as this talk has been, I'm excited because you're speaking the truth about this, and it's refreshing. So thank you for having the chance to talk with you.